Hello everybody, Noble Demon Lord here, and welcome to another space reaction video, this time for Artemis 1. The Artemis 1 launch is tonight, which is super awesome. I am super stoked. So obviously I'm doing this part beforehand. I'll tack in, just like the DART mission, I'll tack in a reaction video at the end, and then just a little bit of a wrap-up beyond that. So let's get right to it. Artemis 1. Um, it is our America's, right, NASA's first mission to the moon with a super heavy lift vehicle since the last Saturn missions or Apollo missions, right? So, interestingly enough, Apollo 17 had a wet dress rehearsal today, 50 years ago. Super cool. Um, Fun fact there, right? So, Artemis 1 is unmanned. There's nobody in it. We've got a couple of mannequin robots inside of it to test just the forces and certain other background radiation and other things that astronauts will perhaps encounter on their way to the moon. Artemis 2 will be a crewed flyby, and Artemis 3 will be a lunar landing. Super awesome. So Artemis 1, right? It got stacked back in October of 21, which, oh my gosh, over a year ago now. But there's been a bunch of delays. So initially, this was, they were going to launch it years ago, and it got pushed back. And they were going to launch it again, and it got pushed back. And now finally, and they're like, oh, we're going to launch in February 22, and things weren't quite ready, and they pushed it back. And they pushed it back. And 17 August, they started with some testing, right? They rolled it out for launch. 29 August, they had a first launch attempt, but they had some sensor issues, right? Redundant sensor issues, faulty readings, so they scrubbed that. 3 September, they discovered a hydrogen leak, which was allegedly repaired. Allegedly. We'll see what happens. But the next launch opportunity was 27 September, which, of course, Hurricane Ian kind of scrapped that. And now Hurricane Nicole rolled through on, well, 12 November. So as of recording 3 days ago, as of the release of this video 4 days ago. So now 16 November, 1:04 a.m.-ish Eastern Time is kind of the planned launch, right? We'll see how this goes. And if things go well, then I'll be wearing the same clothes and super stoked. It'll be pretty late at night, early in the morning for me while I'll be making this video. If it goes poorly, then, well, I'll open that up in the live reaction portion. But we'll see what happens. So, it's going to launch on the Block 1 variant of the SLS, the Space Launch System. So, it's the first super heavy lift vehicle since Apollo mission days with the Saturn V. Super freaking cool, right? There's supposed to be a Block 1, Block 1B, and a Block 2. And I'll pop, Block 1, Block 1B, and Block 2 there. But the Block 1 mostly, right? You've got some solid rocket boosters, just 2 of them. You've got the core stage, which uses the RS-25 Delta engines, which, in the sense that NASA is not funded well enough, they're recycled. They're used from old space shuttle missions. All of them have previously flown on space shuttles. They've done very well. It's a very good engine. But all together, right, the core, the 4 RS-25 Deltas, and the 2 solid rocket boosters, they produce 39,000 kilonewtons of force, which is over 8,800,000 pounds-ish of thrust, which is awesome. That's freaking incredible. That is like the most thrust of any vehicle, I believe. And then the upper stage, the interim cryogenic propulsion stage, it's an RL-10 Bravo 2 engine. So that one, it uses cryogenic hydrogen and oxygen, and it'll produce not nearly as much as 39,000 kilonewtons of thrust, which, sure, okay, I get it. But looking more like 110 kilonewtons of thrust per engine in vacuum. So, like, 110 kilonewtons, 39,000 kilonewtons. one has to get through the atmosphere and get out of Earth's, not get out of Earth's gravity well, but at least, get into a stable free fall or orbit around the planet. Uh, so the ICPS, the interim cryogenic propulsion stage, will fire its engine to get into lunar orbit, right? A trans-lunar injection. So it will place Orion. Orion is the capsule. It'll place Orion around the moon, as well as it's got 10 CubeSats on, that'll all deploy. Um, but at that point, it's going to pop off the ICPS. It'll cruise, coast, I suppose is the correct term. It'll coast to lunar space. Um, but it's going to spend like 3 weeks or more in space. Officially, it's like 25 and a half days to like maybe 42 days ish, just depending on how much they want to get done there. But they're looking for a 6-day kind of a distant retrograde orbit, and a DRO, right, a distant retrograde orbit. For those that don't know, it's when a spacecraft orbits a satellite or a moon that is essentially stable because it's between two Lagrange points around the planet and moon system. So essentially, places where the forces of gravity between the two bodies are extremely stable. You're not going to get any too many perturbations. You're not going to get caught up in tides that you're not expecting. But a little bit, right, timeline-wise, we're expecting about 2 minutes and 12 seconds of solid booster burn. And main engine cutoff will be about 8 minutes in. 8 minutes and 4 seconds is the plan. But solar arrays should come out just past 18 minutes. You've got a couple of raise maneuvers just under an hour in, 53 minutes and 54 minutes for that. And then the trans-lunar injection burn begins at 1 hour and 33 minutes. And that's a 20-minute burn, just about. I got to do some math. It's a 18-minute burn. It's just, right, 18 minutes. It is what it is because it's not as powerful of an engine or thrust setup, right, as the main system. But the main system, right, is carrying tons of weight, fuel and the metal parts and all that, and is fighting Earth's gravity and the atmosphere. So, when you have a smaller engine and smaller mass, it's still going to take time to get a proper burn. And it's like a more of a direct course. I know in a lot of my Kerbal Space Program games, playthroughs, whatever you want to call them, I try to use the Kerbal's gravity to assist me as I launch myself out to the moon. And in this case, it's not a huge gravity assist. You're not really able to do that anyway, not unless you make a weird, crazy orbit. They're just trying to get up into a stable orbit and then just burn pretty much directly at the moon. They're going to get real close, within 60 miles of the lunar surface, for a lunar gravity assist. And that's on day 6. So it's going to take 6 days to get out that far. But it'll be absolutely amazing, once we actually get there. But it'll get down roughly, anywhere from day 25 to 42. We'll get re-entry and splashdown in the Pacific. Looking for the USS Portland to pick it up. It's a amphibious transport ship from the Navy. So, keep an eye out for that in the next month or so. But they've already done tons of testing on this first Orion capsule. Obviously, there's more on the way. They're not necessarily going to reuse them. They've got tons of different contracts. That's one of the reasons why NASA's got the Artemis 1 mission delayed, was their administrative inability to take care of their contracts or contractors and make sure that they actually get things done. Typical kind of government organization. NASA, in my opinion, needs way, 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 way more money, way more funding, and then they won't have to worry about that sort of thing. But they have to work with a lot of commercial partners nowadays to make things happen, and sometimes it's just how it is. But yeah, so here the SLS originally the SLS system was supposed to launch somewhere in 2017. NASA was going to make it Exploration Mission 1, and that kind of outlined that in 2012. And yeah, didn't really work. Now, did it? Um, but yeah, there've been a ton of delays since then. But the service module for Orion was built by ESA, um, the European Space Module. But at the moment, right, it's unsupported, right? It doesn't have, it's uncrewed. That's maybe the right word for it. Uh, but it's an unmanned mission, right? So it'll still have complete life support. It'll have the crew seats. Like I said, it'll have mannequins in there. Um, but yeah, so super freaking cool. There's a bunch of payloads on here. So the first mannequin or Moonikin, Captain Moonikin Campos, named after Arturo Campos, a NASA engineer from the Apollo program. Fun fact. But it got radiation sensors and an Orion Crew Survival System unit, which is kind of what the astronauts will wear during launch, entry, and other kind of dynamic phases. His seat will have different pressure sensors, acceleration, vibration, all that data. There are two phantom torsos, Helga and Zohar, who will take part in, it's called the MARE, or Matroshka Astrorad Radiation Experiment, which is kind of a joint experiment between NASA, the German Aerospace Center, and the Israel Space Agency. But Zohar, that torso will be shielded with the Astrorad radiation vest, and Helga will not wear a vest. So in this case, they'll kind of like one's a test variant, right, to see how useful this radiation vest is as a protective piece of equipment like PPE, versus somebody who's not wearing one. Um, so yeah, in addition to that, Snoopy will be on board, um, as well as ESA Shaun the Sheep. So everybody likes to have their cute cartoon mascots, right? But at this point, they're doing as much as they can with the money they have and all the delays they've gone through, right? And they want to get as much science as they can out of it. So 10 secondary payloads, right? CubeSats. We're looking at Argo Moon, BioSentinel, CubeSat for solar particles, Eculeus, Lunar Ice Cube, Lunar Polar Hydrogen Mapper, Near Earth Asteroid Scout, Omotenashi, Lunar, Team Miles, Cis-Lunar Explorers, Lunar Flashlight, and Earth Escape Explorer. I know it's a lot, but essentially they're doing space science, right? You're looking at how radiation affects yeast samples. You're taking images of the plasmasphere, Earth's plasmasphere, any impacts on the moon's far side. You're looking at ice collection data for infrared spectrometers, looking for organic components, especially lunar water ice in the kind of the permanently shadowed craters, more like toward the poles. And that's kind of what Artemis is looking at as all southern landing sites, just so they can see if they can find water or any other sorts of things there. But yeah, there's lots going on here. I am super excited as we kind of get closer to launch time, and I'm gonna have to come back here and sit down and record and hope that the weather holds out for Artemis. It'll be really interesting watching it with nighttime rather than daytime, you know, color, right? It's just going to be a bright flare probably once it launches. Um, but we'll see. So, other than that, right, the biggest deal here is the test of the first super heavy lift system in decades. The Space Launch System is going to be hopefully a mainstay of future space exploration, right? I'm I'm cool with private space exploration. That's cool, right? As long as you advance science, you're doing it for the betterment of mankind, not just to line your own pockets. Um, but manufacturers, right? NASA can't just manufacture everything in house, especially for a project this large. So Aerojet, Rocketdyne, Northrop Grumman, Boeing, United Launch Alliance. There's a lot of people in here that kind of have their hands in the system amongst all the other space agencies. But this is a $23 billion U.S. system. Uh, Now, per launch, estimated, it's $2 billion per launch, which is an insane amount of money for normal lay people, right? But for a government that's collecting taxes, that ain't shit. That's minimal. Um, but yeah, it is a it's so cool. I'm super excited to see how this system works. And like I said earlier, there's Block One Bravo, and a Block Two system, right? So Block One's obviously the initial system um, with some shuttle-derived boosters, and then Block Twos will have new kind of advanced boosters. But Block Two uh, up will be up from the 8,800,000 foot-pounds of thrust to 9.2 million, which is insane, or 39 meganewtons to 41 meganewtons, or 39,000 kilonewtons to 41,000 kilonewtons. Uh, Now, here's the thing, right? With weight, um, low Earth orbit, the Block One can get 209,000 pounds, or 95 metric tons of payload to low Earth orbit, which is insane to me. The one Bravo will up that to 231,000 pounds, or 105 metric tons, and the Block 2 is 290,000 pounds, 130 metric tons, which is insane. Or 46 metric tons to a lunar injection, or 99,000 pounds, or 45 metric tons to a heliocentric orbit around the sun, which is crazy. Absolutely amazing. So hopefully we actually get there, right? Um, so really, the only comparable rockets, right, are the Saturn V, like maybe the Falcon Heavy, maybe not really, because the Falcon Heavies they still put out quite a bit of thrust, but like 22 meganewtons, like come on, man, that ain't nothing. That ain't nothing compared to the Space Launch System, the SLS. Um, Now, hopefully, we actually NASA gets the money to actually keep up the SLS system and more launches to the moon, right? Notably, I think the Artemis Accords, which is kind of the legal agreement of how the world is going to use the moon as a resource. I don't think it should be used as a resource. I think it needs to be left alone. Now, when you take like asteroids, sure, let's go mine some asteroids. Um, I don't know how people are going to feel about strip mining the moon. I don't think we should do that. That sounds stupid and very short-sighted. But there's lots of debates on how useful or how cost appropriate that would be, and also just the aesthetic point of we already are messing up the planet itself. Why are we gonna mess up more of the moon? Asteroids are just kind of out there, and they're just rocks. I mean, the moon's just a rock too, and it's just out there. But anyway. But the Artemis Accords, some people are thinking that it's kind of a short-term, kind of plays into American interests for mining. Others are just hoping that they can kind of extend the United Nations Outer Space Treaty from 1967. Kind of hope that people are going to be peaceful about space, right? We can have our quarrels and squabbles here on the planet, but you know, hopefully have a peaceful uh, exploration and scientific basis of all of our work in space. Now, those parties, there's plenty of folks anywhere, between the United States, the Isle of Man, Brazil, Colombia, Canada, Italy, Japan. There's a bunch of other countries there. Um, but yeah, it's incredibly important for humanity to move to move into space, right? We need to not necessarily escape Earth. That's not the right terminology. We need to grow. We are a growing race. We need our growing civilization that needs to step out to the stars. We need to learn. We need to grow. We need to take care of what we have. We need to take care of our people. We need to take care of the planet that we live on, because when this planet's gone, if we don't figure out our lives, we're just going to end up in the cold darkness of space, which is not okay. Uh, but kind of stepping away from the philosophical, right? I'm just excited for this launch. I am very, very, very excited. I am excited for the Artemis program as a whole. I am excited for the next 7 Artemis missions on top of that. I'm excited for the Lunar Gateway. That Lunar Gateway is important. That is kind of one of the ways that the uh, the world, right, will have access to the moon. It'll get another space station around a different body, right? So we have the International Space Station, the Chinese space station is the Tiangong. I'm gonna really screw that one up, so I apologize. But the Tiangong is up there. We used to have the Mir back in the day. Um, but yeah, so now we have the Lunar Gateway, which will eventually launch in 2024, allegedly. We'll see how that goes. But that should be on an SLS Block 1 Bravo. But that should help us kind of expand, right? Science, living in space. It'll help get to the moon and back, make it much easier. Some argue that it's not cost effective. I think it's cool. I like it. Um, but it's going to be a United States centric or U.S. centric system, right? And ESA as well. Uh, Roscosmos didn't want to take part in it. Um, that's okay. We don't need Roscosmos anyway. But yeah, it'll be kind of a deep space habitat, right? But hopefully, it's actually going to be able to work. So uh, for that, right, that'll help future Artemis missions. So Artemis 4 should be docking with the Gateway or the Lunar Gateway, um, hopefully in 2027 ish. But yeah, we'll get lots of different modules, anything for refueling, habitation logistics, power and propulsion. All of these things will help keep the space station in orbit around the moon, right? It'll help astronauts survive, and we'll just have to see, right? I am super excited, so rather than me just kind of ramble on about how the systems may or may not work, we're just going to get right to it, and I will see you guys right back here for the launch. Ooh, there's the gimbal test.
Each RS-25 throwing down 500,000 pounds of thrust.
Oh my gosh.
All 4, 2 million pounds. All together with the boosters, 8.8 million pounds of thrust.
Go for upper stage to internal power.
Now the upper stage has gone to internal power.
We ended up a little late.
From the rocket's upper stage,
that's okay, we got go.
And it's been switched to battery power.
As you guys can see, this is NASA's official stream.
Core stage at T-minus 1 minute and 30 seconds.
Ooh, boy. Oh man, I'm anxious. This is it's a big day. Morning, night, whatever you want to call it. Nice.
The rocket's core stage, which houses the 3 flight computers, is now on battery power. So there is no more hold time available because there's no more margin on the batteries. So if we have a hold, we'd have to recycle back to T-minus 10 minutes and recharge those batteries. The count continues. A note now, shortly after liftoff.
1 minute.
1 minute.
Shortly after liftoff, Mission Control Houston will take control of the rocket, and my colleague, Leah Cheshire, will take over commentary. T-minus 50 seconds
Oh my
and
God,
counting.
this is amazing.
Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the autonomous launch sequencer. On board the rocket, it will take over command and control of the rocket. But the ALS will check, make sure there's no holds coming from the ground up until
There's
T-minus
33
GLS,
seconds.
Go for ALS.
and we are go for
Yes!
ALS. The Space Launch
Whew.
System is now counting down to liftoff of Orion.
Oh,
and
I'm like
its
shaking.
maiden voyage to the moon. Launch team can no
20.
longer cycle the count.
20 seconds.
Sound suppressor water now flowing
15.
under the ML.
Oh.
And here we go.
Oh.
Hydrogen burn-off igniters initiated. 7, 6, 5, 4 stage
Oh.
engines start.
Oh.
1. Boosters
Yes!
ignited. And liftoff of
Yes!
Flight 1. We rise
Whoa.
together back to the moon.
Wow.
And beyond.
Wow, what a rocket. Wow. What a rocket.
All 4 RS-25 engines on the core
Holy
stage, 2 solid
crap.
rocket boosters now propelling the vehicle at 128 miles
Wow.
per
Oh, that's so cool.
hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1.
Holy crap.
First milestone will be for the vehicle to pass through max Q in about 1 minute and
Max
9
Q.
seconds into launch. This is the greatest period of atmospheric force on the rocket.
Wow.
SLS now traveling 607 miles per hour.
Wow. Oh, it looks fake. That's amazing.
You're looking at 8.8 million pounds of maximum thrust.
Oh,
flying
hitting
here
hit some
in the loop
some
of
clouds now.
control. Full course
Wow.
engines throttling down ahead of passing through max Q.
Wow. That would be awesome to be there in person. I wish I was there in person.
Now 1 minute 21 seconds into
Oh
the flight,
my
traveling
gosh.
1,420 miles per hour.
Another minute or so and those solid boosters will cut off.
Core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and
Wow.
9 seconds into the flight, so about 30
Oh, that's
seconds
cool.
from now.
Oh, camera, get it.
Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis 1.
Oh my God, that's amazing.
We're now 16 miles downrange from the launch pad. at
16
Space Center,
miles.
traveling over 2,800 miles per hour.
Wow. Oh, that's great. Oop.
Standing by for solid rocket booster jettison and shortly thereafter.
Oop. We jetting? We gonna jet?
Confirmation that
Yeah.
the solid rocket boosters have separated.
Yes!
With 177-foot boosters.
Yes!
Now the core stage continues to power the flight of Orion on over 8 RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange.
Wow. Oh my
2
God.
minutes and 36 seconds into the flight.
Yes!
Hearing nominal calls here in Mission Control Houston. We've still got 4 good
Ooh,
engines
that's
on
cool.
the core stage. Next up, we'll be looking for the service module fairing to separate. This is 3 15 by 15 foot fairing panels, providing structural support, protecting the service module.
Oh man.
Those will separate at about 3 minutes and 11
This is a
seconds
really
into
cool
flight, and very shortly thereafter will be followed
display.
by the launch abort system separation.
Holy crap.
Just over 3 minutes into the flight of Artemis 1, now traveling over 4,060 miles per hour, 83
Wow.
miles downrange.
Wow.
We just had confirmation that the service module fairing has separated.
Oh, onboard cameras. Oh, maybe? Nope.
And that the launch abort system pyros have fired, separating those from Orion as
Oh,
well.
so cool.
For future crew members.
Well, we lost sound. That's maybe not good. Oh, that's a cool frame.
We just heard the call for 3-engine press, meaning if SLS were to lose an engine at this point in the mission, we could still achieve a nominal mission. We would just have an extended main engine cutoff
Hell
time.
yeah.
However, we still have 4
Oh
good engines
my
on
God.
at maximum thrust
Absolutely
right now,
amazing.
powering the first flight of
Wow.
Artemis at 5,200 miles per hour, 148 miles downrange.
Absolutely amazing. Yeah. Wow. Holy crap. I don't even know what to say anymore. This is absolutely amazing. Beautiful launch. Congratulations to NASA, the
We're
ESA,
4
the
minutes and
Japanese Space
16
Agency, the
seconds
Canadian
into the
Space
flight of
Agency.
Artemis 1. So far, we've had a clean ascent. We saw those solid rocket boosters jettison about
Wow.
2 minutes and 11 seconds after
Congratulations.
liftoff. Shortly after, we had the service
I'm
module
sure
panels fairings
I'll do a
separate,
video for
as
when
well as the launch
Artemis
abort
1
system. The launch abort
Orion
system was
returns to
inert for
Earth.
this flight,
But for now,
except to perform this separation.
that's how this is going to go. I just want to see if this separation
Those 4 core
happens.
stage engines will continue to fire and power the flight of Artemis 1, now traveling over 6,800 miles per hour,
Wow.
229 miles downrange.
Holy crap.
Booster flight controller reports that the engines
Wow.
are looking good.
Wow. Wow.
Our core stage main engine cutoff time is about 8 minutes and 3 seconds. We are
Wow.
now 5 minutes and 11 seconds into the flight, 7,656 miles per hour.
Wow. Holy
Again,
crap.
4 good core stage
This is
engines, those
amazing.
4
I'm
RS-25 engines.
blown away by the ingenuity, the math, the engineering,
taking spaceships to orbit. Now with upgraded capabilities, they're launching the
everything
future
that
of
it
human
takes.
spaceflight.
Everything that it takes to get a mission like this off the pad. And
5 minutes, 42 seconds into the mission, we are now traveling 8,800 miles
that's
per
so
hour,
cool.
345 miles downrange from the launch pad at Kennedy Space Center.
I know it rolled back, we scrubbed 5 times, but who cares? If you have 5 good scrubs, you get one good launch.
Cutoff at about 8 minutes and 3 seconds.
You don't want to end
about
up
10 seconds later, we'll see core stage separation, at which point Orion and the interim cryogenic propulsion stage will be flying free.
Yeah, we don't want to not scrub and then have
now
a mistake.
Traveling over 10,000 miles per hour, 6 minutes and 15 seconds into
my
the flight.
gosh.
Artemis 1, 427 miles downrange.
Wow.
Quiet here on the loops in Mission Control Houston. Teams continue to monitor this first flight.
My God. Astounding. Absolutely astounding. I am so happy. I think they did an excellent job.
About a minute and a half now until that core stage main engine cutoff time. Our 4 core stage engines continue to fire maximum thrust.
Whew. Holy shit. They did an absolutely amazing job. Wow. I don't even really have too much to say other than congratulations, and I'm
Coming up on 7 minutes since launch today, now traveling over 12,800
I'm gonna sit here for one more minute until we
563
have
miles downrange.
main
Again,
core separation,
still
and then
quiet
I'm
here
gonna
in
call it a
Mission Control
night.
Houston.
But hey, quiet is good. I would rather have quiet than anything else. The less that we have to worry about, right?
As we prepare for main engine cutoff,
The less they talk.
4 RS-25 engines are beginning to throttle down.
Wow. Stunning. I can't wait for more photos and video to come out of this. It's going to be absolutely stunning. I'll play what I can through
30 seconds now until
my
main engine cutoff.
Orion landing video.
Continue to throttle down.
But as long as we get core stage separation, that's what I care about.
Now 7 minutes 45 seconds into
Almost
the flight,
there.
traveling over 16,000 miles per hour.
Wow.
Continuing to
I'm just
good
stunned,
here
really.
At Mission Control Houston. We're standing by for core stage main engine cutoff.
Whew. Come on, main engine cutoff. You can do it. Just about there. Hey, if the rest of this mission goes swimmingly,
And we
sounds
have
good to me.
confirmation of core stage main engine cutoff.
Ooh.
Orion is now in Earth's orbit.
Nice.
The flight dynamics officer reports that we have a nominal
Yes!
main engine cutoff. And we just heard the call for core stage separation.
Beautiful.
That means Orion and the interim cryogenic propulsion stage
Absolutely
are
amazing.
now flying free from the core stage of the Space Launch System.
Yes!
The next milestone will be solar array deploy approximately 18 minutes after liftoff.
Wow.
But before Orion stretches
So,
its wings, let's check back in with our friends at Kennedy Space Center and hear all about what it was like to hear.
Wow. Um, Holy crap. Absolutely amazing. Um, I don't even know what to say here anymore, other than I am absolutely blown away uh, by the incredible work of the engineers, of the mathematicians, of the PA people, of anybody who got funding for this, anybody who built on any of these parts or worked on them. Congratulations. But yeah, that's what's gonna do for me tonight. Noble Demon Lord here. Thank you guys so much for joining me for this wonderful experience. I'll see you guys next time. See ya.
1 minute.
Shortly after liftoff, Mission Control Houston will take control of the rocket, and my colleague, Leah Cheshire, will take over commentary. T-minus 50 seconds and counting. Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the autonomous launch sequencer. On board the rocket, it will take over command and control of the rocket. But the ALS will check, make sure there's no holds coming from the ground up until T-minus 2
GLS
seconds.
is go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can
20.
no longer recycle the count. Sound suppressor water now
15.
flowing under the ML. And here we go.
10.
Hydrogen
GLS
burn-off igniters initiated. 7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour. You're looking at 8.8 million pounds of maximum thrust. Quiet here in the loops in Mission Control. The 4 core stage engines are throttling down ahead of passing through max Q. Now 1 minute, 21 seconds into the flight, traveling at 1,420 miles per hour. The 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis 1. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour. Standing by for solid rocket booster jettison and shortly thereafter. Confirmation that the solid rocket boosters have separated these 177-foot boosters. Now the core stage continues to power the flight of Orion, all 4 RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange.